Hello students, here we have a question from JEE 2023 8th April first shift. The question is related to the nuclear physics, in which they were asking something about the surface energy of nucleus, volume energy of nucleus, Coulomb energy of nucleus, etc. The question is like mark the correct option and four statements were given. So among those four statements we have to find the one of the correct option. Here are the options I have given on the basis of the memory of some of the students. The question is like mark the correct option. Then they have given the first option related to surface energy of the nucleus. Surface energy of the nucleus is the reduction in binding energy due to nuclear surface effects. Then second option was like related to that one closely packed nucleus is having how many nearest neighbors. Then third option is related to the surface energy expression. Is it equal to K1 a to the power 2 by 3, where K1 is a positive constant and a is the mass number. And volume energy of the nucleus is given like K2 into Z minus 1 a to the power 1 by 3 by 2, where K2 is a positive constant and Z is a atomic number of the atom. Now this is what the question is. Now in the question what's the specialty is, it is related to surface energy of nucleus and the concept which are somewhat of higher level. If I see from the physics point of view, it is a very nice concept, nice theory, and it is on the basis of the liquid drop model of the nucleus, which itself is a research type topic, means for which a lot of research is needed, means on this topic. But when I see it from the +2 level, at the entrance level like JEE Main, etc., then this is well outside our syllabus. I am explaining you about here this concept behind this question. The concept behind this question is related to the liquid drop model of the nucleus. Now, what is this liquid drop model of this nucleus? In this particular model, what the scientists have considered, they have considered the nucleus as a liquid drop. They said nucleus cannot be considered as solid. Rather, they have said how we can consider the nucleus as solid. Why they cannot consider as solid? Nucleus is consisting of some nucleons, neutrons and protons, which are moving inside the nucleus. So it means nucleons themselves are behaving as solids. Now, if we consider the whole of the nucleus as the solid, then it is some solids inside a solid. Right, so it is not correct to consider nucleus as a solid, and on the basis of this, some people have said that instead of this, if we say nucleus as a liquid, and they considered it as a liquid drop. For this, what is happened? They said nucleons are moving inside the nucleus just like the liquid molecules are moving inside a liquid drop. In this way, they have considered here. Now the given question, the question which has appeared in the JEE Main 2023 8th April, is related to the binding energy of the nucleus related to this, which is explained by this model. As such, if we see the binding energy in normal theory, we say binding energy is the explained on the basis of the excess mass, extra mass, that is mass defect, and it is equal to delta mc square, or the minimum energy required to break the nucleus into its constituent particles, etc. That is a very common concept, we all know. Now, after that, if we see from this particular point of view, from this particular theory, the binding energy of the nucleus is contributed by 5 ways. Contributed in 5 ways. These 5 ways are, you can see this part, you see the volume energy, surface energy, Coulomb energy, asymmetry energy, and pairing energy. Now, first contribution is volume energy, which is proportional to the number of nucleons. So, volume energy is proportional to the number of nucleons. Surface energy is the reduction in the binding energy due to nuclear surface effects. I'll explain you the meaning of this word. Nuclear surface effects means what, and entire things also I will discuss. And third is the Coulomb energy, which is arising due to the repulsion between the protons. Then fourth one is the asymmetry energy. This asymmetry energy is causing the reduction in the binding energy, which is arising due to unequal number of protons and neutrons. And the fifth one is pairing energy, which is somewhat not actually explained by this theory also, but it is accounting for the stability of the even and even odd nuclei, etc. Now, here first three particular points we'll discuss in detail, and the remaining one is not needed. Now, what happens? We know something about the nuclear force, that this is a short range force. A nucleon is in interaction with the surrounding nucleon only for a femtometer distance, only for a very small number of nucleons, neighboring nucleons, it is in interaction with the help of the nuclear force. So, volume energy has been explained on this basis only. Actually, it is proportional to the number of nucleons. It is proportional to number of nucleons. So we can say that volume energy is proportional to number of nucleons. One expression is there that volume energy of nucleus is K2 into Z, Z minus 1, A to the power by 2, 1 by 3 by 2. So it means this particular expression becomes wrong. This is wrong. Now, here in this theory, it has been told that every nucleon is means nucleon, which nucleon? Which is deep inside the nucleus, means closely packed nucleon. It is in interaction with the 12 neighboring nucleons. It is having the 12 nearest neighbors, and the energy of the nucleus is contributed by, means volume energy is contributed by these 12 nucleus. Now that energy is coming out to be proportional to A. Now they are saying what is the surface energy. Now here one nucleon, which is, you can say, closely packed nucleon, it is in interaction with 12 closely spaced nucleons. But at the surface, the number of nearest neighbors is not going to be equal to 12. It is going to be less. And the surface energy, this particular thing is known as the surface effect. If you see this particular statement, surface energy of nucleus is the reduction in binding energy due to nuclear surface effects. Now, nuclear surface effects means the number of nucleons on the surface is not the same as the number of nucleons inside the nucleus. And the nearest neighbors of a nucleon on the surface is not equal to 12. Closely packed nucleons deep inside the nucleus is having the 12 nearest neighbors, but the surface nucleons are not having the 12 nearest neighbors. In this way, this statement also proves to be wrong. Now, how to find the surface energy? This statement is right, because surface energy has been defined in this way. Now, how to find the expression for the surface energy? Now, surface energy is related to number of nucleons on the surface, and number of nucleons on the surface is proportional to the surface area. Now, surface energy is proportional to surface area. of the nucleus. Proportional to surface area is 4 pi r square if I take the radius of the nucleus as r. Now we know r equal to r naught a to the power 1 by 3, so it can be written as 4 pi r naught square a to the power 2 by 3. So if I remove the proportionality sign, I can say k1 into r naught square, 4 pi will also come, a to the power t by 3. This I can write some constant, say k1 dash, a to the power 2 by 3. Since this surface energy is the reduction in the binding energy, this surface energy is the reduction in the binding energy due to surface effect, nuclear surface effect. That's why it will be negative. So surface energy is equal to minus k1 dash a to the power 2 by 3. If we see the option here, k1 is a positive constant. So this option is also wrong. Now after that we have the Coulomb energy. Now this Coulomb energy is due to the repulsion between the protons. Protons repel each other, and this Coulombic repulsion force between the protons is proportional to 1 by r. This is proportional to 1 by r equal to r naught a to the power 1 by 3. So we can write it as 1 upon r naught a to the power 1 by 3, or it is proportional to 1 upon a to the power 1 by 3. Now, if in a particular nucleus Z protons are there, then total number of pair of protons will be easily, from the mathematics you can say permutation combination, that Z Z minus 1 by 2 pairs will come. For atomic number Z, if Z is the atomic number, then total number of proton pairs, total pair of protons. Why we are considering total pair of protons? Why it is needed? Because we want to find that how many interaction forces are there. So it will be Z into Z minus 1 by 2 pairs of protons will come. Now, then the Coulomb energy will be, Coulomb energy is going to be, we can say, these many pairs, and one is proportional to 1 upon r. Between one particular between two protons, Coulomb repulsion energy is proportional to 1 upon r. So energy due to Coulomb repulsion or Coulomb energy will become of the nucleus is Z Z minus 1 by 2 into 1 upon r, that is Z Z minus 1 by 2. R is proportional to a to the power 1 by 3. This can, and proportionality constant will come now some here, so we can write some constant, say k3. It is equal to k3 Z into Z minus 1 by 2 into a to the power 1 minus 1 by 3. Since this is causing the reduction in the binding energy, this Coulomb repulsion between the protons is causing the reduction in the binding energy. That's why this binding energy, this EC, the Coulomb energy of the nucleus will be negative. And so we can say equal to minus K3 Z Z minus 1 by 2 into a to the power minus 1 by 3. So this is the Coulomb energy. And about the remaining two, the asymmetry energy and the pairing energy, they are something, their detailed explanation are well, is like a research area type thing. So I'm skipping out that there. So here in short, I can say, I'm summarizing it. This question is related to the, on the basis of the liquid drop model of the nucleus. In that liquid drop model of the nucleus, nucleus is not considered as solid, but rather it has been considered as a liquid. In that, the binding energy of the nucleus is explained due to the 5 contributions. On those 5 contributions are, one is the volume energy, surface energy, the Coulomb energy, pairing energy, and the one more is there, asymmetry energy. Now this volume energy is proportional to number of nucleons. Surface energy is proportional to this one, This is the surface energy proportional to a to the power 2 by 3. Coulomb energy is proportional to a to the power minus 1 by 3. Coulomb energy is causing the decrease in the binding energy, and it is due to the repulsion in the between the protons. Surface energy is also causing the decrease in the binding energy, and it is because of the nuclear surface effects, because surface nucleons are not having the 12 nearest neighbors, while the volume energy is going to cause the means contribute in the positive way in the binding energy, and it is proportional to the number of nucleons. Overall, this question is well not within the scope of the JEE main, but a nice question overall. I hope you have understood this. Good day.